You know, in our world today, network downtime is more than just an annoyance. It can be a total disaster. Everything, and I mean everything, from your laptop to critical servers, just expects a rock-solid connection. So what happens when the one device that handles all that traffic just dies? Well, that single point of failure is exactly what we're going to solve today with a really elegant solution: Cisco's Hot Standby Router Protocol, or HSRP.
So, here's our game plan. We're going to start by finding the weak link, what I call the gateway's fatal flaw. Then, we'll dive into the clever trick protocols used to create this illusion of perfect uptime. After that, we'll get into the nitty-gritty of how HSRP actually works, watch what happens during a real failover, and then we'll wrap it all up with the key things you need to know for building these kinds of high-availability networks.
All right, let's dive right in. Before you can build a network that never goes down, you've got to know where it's most likely to break. And trust me, there's one vulnerability that is just hiding in plain sight in almost every network.
So let me ask you this. Just think for a second about a typical network. Where's that one single point of failure that could knock everyone offline in a heartbeat? It's usually a device you set up once and then completely forget about. Well, until it's too late.
And here it is, the Achilles heel of so many networks, the default gateway. See, your PC, my PC, every device out there has a single static IP address pointing to its gateway, in this case, router R1. If that router goes down, that's it. Your PC has no idea there's another path. It'll just keep blindly sending traffic to a dead end. So even if you have a perfectly good backup router, R2, sitting right there, it doesn't matter. Your PC is completely blind to it. Having extra physical gear doesn't mean a thing if your network logic can't use it.
So how do we fix this? I mean, we can't run around to every computer and manually change the gateway every time something fails? No, the solution is way more clever. It's kind of like a technological magic trick. We create the illusion of a single gateway that never, ever fails.
And the secret to this trick is the virtual router. Now, this isn't a physical box you can go out and buy. It's a logical concept, an abstraction that's shared between two or more real routers. This virtual router gets its own IP address and its own MAC address, and that is what we tell all our computers to use as their default gateway.
So check this out. Here's how it actually works. You've got R1 and R2 working as a team, but from PC1's point of view, it has no idea. It's just talking to one virtual IP, let's say 192.0.2.100. Behind the scenes, only one of those physical routers is actually doing the work. But the PC is completely oblivious. And the best part? If that active router dies, the other one takes over instantly, and the PC never even skips a beat.
So how does this magic trick actually work? It all boils down to a process called ARP, or Address Resolution Protocol. It's basically how devices on a network find each other's hardware addresses. When the PC needs to send something to the gateway, it just shouts out an ARP request like, "Hey, who has the gateway IP?" The currently active router, and only the active one, answers. But here's the crucial part. It doesn't reply with its own physical MAC address. It replies with that special, shared, virtual MAC address. Because that IP and MAC combo never changed from the PC's perspective, it has no idea a massive failure and recovery just happened. It's seamless.
Okay, so this whole idea of a virtual router, it's the foundation for a whole class of protocols we call first-hop redundancy protocols. Now, let's get specific and zoom in on one of the most popular ones out there, Cisco's Hot Standby Router Protocol, or HSRP. In the world of HSRP, routers get assigned jobs. You have one, and only one, active router. This is your quarterback, the one handling all the traffic that's sent to the virtual gateway. All the other routers in the group, they're in the standby role. They just sit there, listening silently, monitoring the health of the active router with these little heartbeat hello messages, just waiting for their chance to jump in.
So you might be wondering, how do they decide who gets to be the active one? Well, it's an election, and it's all based on priority. Each router gets a priority value from 0 to 255. The default is 100. And it's simple. Just like this seesaw, the router with the highest priority wins. It gets to be active. If it's a tie, the router with the higher IP address wins. Pro tip, you should always manually set a higher priority on the router you actually want to be your primary.
Now, a router doesn't just wake up and decide to be active. It actually goes through a whole life cycle. It starts in an initial state, then it has to learn the virtual IP. After that, it just listens for hello messages to see who else is out there. Then it enters the speak state where it starts sending its own hellos and actually votes in the election. From there, it'll either become the next in line standby router, or if it wins, it'll become the active router and start forwarding traffic.
All right, we've covered the setup, the theory, now for the main event. What actually happens when that active router fails? How does HSRP pull off that seamless recovery we've been talking about?
It all comes down to timers. By default, the active router is constantly sending out a little hello packet every 3 seconds. It's basically shouting, "I'm here, I'm alive." That's the heartbeat. The standby router is listening for that heartbeat, and it has its own timer called a hold timer, which is usually 10 seconds. If the standby router goes for 10 full seconds without hearing a hello, it assumes the active router is dead, and it's time to take over.
Let's walk through it. In this first panel, everything's great. Router A is active, happily sending out its hellos. In panel 2, disaster strikes. Router A fails. The hellos stop. That 10-second hold timer on router B starts ticking down. As soon as it hits 0, boom, router B promotes itself to active, it takes over that virtual IP and MAC address and immediately starts forwarding the PC's traffic. The whole thing happens in about 10 seconds and the connection is restored. Okay, so router B saved the day. Awesome. But what happens when our original, maybe more powerful router, router A, comes back online? Well, by default, nothing. Router B would just stay active. That's where this feature called preemption comes in. When you turn it on, it lets a router with a higher priority basically say, "Hey, I'm back and I'm the boss. Let me take over again."
Let's follow this cycle. Router A, our heavyweight champ with the priority of 150, fails. Router B, with a lower priority of 100, steps in and becomes active. A little while later, router A reboots and comes back online. Because preemption is turned on, it looks around, sees a lower priority router is in charge, and it forces a new election to reclaim its role as the active router. This makes sure your network is always using the best, most optimal path whenever it's available.
And there you have it. That is HSRP in a nutshell. It's a pretty simple but incredibly powerful protocol for building networks that can take a punch. Let's just do a quick recap of the most important ideas.
So let's boil it all down. First, the whole point of this is to get rid of that single point of failure by creating the illusion of a virtual router. Second, the leader is chosen through an election based on priority. Highest number wins. Third, you can use preemption to make sure your main router always takes back control once it's healthy. And finally, this whole thing is governed by simple timers. A constant 3-second heartbeat, and if that heartbeat is missed for 10 seconds, it triggers a seamless failover.
Look, HSRP is an absolutely critical tool for gateway redundancy. But as we finish up here, I want to leave you with a question to chew on. We've solved the problem of a failed router, right? But what if the router itself is perfectly fine, but the switch it connects to fails? Or maybe its main link to the internet goes down. HSRP on its own can't detect those things. And that opens up a whole new level of high availability design, using even smarter features to build even more resilient networks.